Okay, our next question is regarding alkenes. So I've chosen pentene, I've chosen pent-2-ene. 2 because the functional group, which is the double bond, is starting on the second carbon. So we call this pent-2-ene. The first thing we're asked to consider about our alkene is what will happen, again, looking at halogenation. So there's a slight difference with an alkene or an alkane when you're looking at halogenation. We need to have a think about this double bond. When we put our halogen, and again I'm going to go with Cl2 as my halogen, when our halogen comes along and this functional group is electron dense, there's more electrons than usual here because there's two bonds, not one, making a double bond. So there's electron density here, and chlorine is going to kind of come and interact with that. It's going to substitute what's already there. In this bond that's just been broken, there was an electron from this carbon and there was an electron from this carbon. So this one and this one now have an electron to kind of make a bond with something else, and we've got a Cl2 molecule here. So what will happen is both this carbon and this carbon will make a bond to a chlorine atom. Just to be really clear and to reinforce the idea that the chemistry happens exactly where the original functional group is, let's just imagine what would have happened if we had pent-1-ene. Pent-1-ene would have our functional group, our double bond, starting on the first carbon. So when this becomes a single bond, it's actually this carbon and this carbon that have bonding electrons ready to go. So in this case we would have this chlorine and this chlorine attached. So just be aware when you're drawing in where your chlorines are going to be bonding, they are going to be bonded to whichever two carbons were involved in the original functional group, which was the double bond in the alkene. And then the next bit of this worksheet is asking again about our alkene. And I'm going again with my original 2-ene. And this is asking about a hydrogenation reaction. Hydrogenation is to do with hydrogen, and it means sticking hydrogen on stuff, basically. So again, same idea. If this double bond is interfered with, we've got some hydrogen coming in. Yeah, sorry, just checking the map. Got some hydrogen coming in. The carbons originally involved will have hydrogens here. They also have another hydrogen because, do you remember we infer the hydrogens? If we can see corners and ends of lines, they are carbons, and the lines between them are the bonds. This carbon here, we have 1 bond, 2 bonds, 3 bonds, and we know carbon will make 4, so there is actually another hydrogen here. And normally when we draw our skeletal representations, we don't draw in the hydrogens, we just infer them. So it would be correct to just draw that as our product. We had pent-2-ene. If we put it through a hydrogenation reaction, the double bond breaks down and instead hydrogen is added across this bond, and you don't have to draw them in, and what you would end up with is the alkane of your alkene. So if I had pentene, I would end up with pentane when hydrogen is added onto it.